Hello, everyone. Welcome to this session. I know it's a difficult one. We have at the same time lunch break, but some of you found the solution. I can see. Thank you for this. So this is a quote from a movie theater, a movie that it's animated called The Lorax. Unless someone like you cares an awful lot, nothing is going to get better. So let's keep that in mind. So discussion here is about how engineers, developers, analysts, people of technology can become the rescuers of today's life. We had a very solid foundation of this discussion from the previous session, where Mark and Alex described several coding practices. And I would like to extend this and discuss about how we can design secure and eco-friendly solutions that are software-based. So first of all, I have two questions to get us started. Number one question, have you ever seen Despacito in YouTube? Just raise your hands if you have. Right? Why I mention this? Because, the 8 billion plays of Despacito actually consumed as much electricity as 8 African countries do in one single year. So if you balance that with what you have enjoyed, what everybody has virtually enjoyed, it makes us think, what if YouTube was just 1% more energy efficient, if the YouTube player was just 1% energy efficient? This could potentially mean that we could supply energy to large cities for a whole year. So another question to make us think, why vehicles have brakes? Any ideas? Safety, it's one answer, yes. Anybody else? So that they can go faster, yes. So it's because of the brakes that we can dare to accelerate and dare to go faster and reach destinations that it's hard to reach. So again, question comes to our minds, what if all devices had some brake protection? So for the next about 30 to 40 minutes, I'm going to present some ideas regarding these two questions, these two areas. And this is, of course, a disclaimer for presenting my own views, but also presenting some of the things that we do in Netcompany Intrasoft. This is a small background for me, but it doesn't really matter. All I wanted to say with this slide is that the really important stuff is that I'm a father of 2 children. I have taught quite a lot of people in a professional and academic environments. And my main aim, my main goal through this discussion is to try to do as much as possible, from my point of view, to leave this planet to the next generation to at least the same condition as my generation has received it. So if you are in the same mentality as this one, this is the right session for you to attend to. So just to begin with, thinking about practical stuff, there's a question why you should be bothered with security. So there are obvious answers to that: to prevent potential attacks, security incidents, things that could go wrong, secure really important stuff, your assets, your sensitive information, your information systems. But eventually what this is all about is to make your customers trust you more. And this might be customers either internally, your own organization, or externally, people that you provide services to. So this is one thing. And the other thing is, why should companies be bothered with security in technical terms, organizational terms, or whatever? So I have a pretty interesting, to my view, statistic here that comes from Ponemon Institute, and these guys are quite, eager to develop statistics regarding information security. And what they present here is that there is a gap in security risks and the allocation of spending. So this is something that it's valid for 2022. And you see that applications, although the level of risks that they have recognized is quite high, it's 33%, it's the greater risk level compared to the other factors that we see here. They don't get as much spending in an annual basis. Whereas networks, which is typically more recognized as a source of risk, which is in reality, this is not the real case, they get much more spending. So organizations start to realize this thing, and they're trying to balance the spendings with the risks. So there is going to be a trend which has already started, as you see here, from spending for networks and raw systems, commodity systems, to application and software-based solutions. So this is something that companies already started having in mind. And what we do basically with software and with such initiatives is we build trust. So we take people, we take processes, we take technology, and we aim to have reliability and resilience for our information and for our services. So if you want to do this in a structured way, if you want to do this, in a way that it's organized and has isolated all potential areas of improvement for security, you could think of all these typical information security requirements. And this is something that you can drill in as much as you want. You can have data encryption requirements. You can have security awareness trainings formed in a specific way. You can have requirements regarding network security. You can also have secure coding practices. And all these together can provide this type of framework that we need in order to establish security within any software-based solution. As it is quite obvious, we won't have the time to explain each one of these and elaborate a lot, but I would like to take the opportunity and present an example from this list. So let's take secure coding, for example. So a typical example within security coding activities is input validation. Input validation comes in many flavors. As you can understand, it's something that can be used in many areas. You can have something like a front-end web-based environment. You can have any type of form or any type of user interaction. And you should be able to verify that this is correct. This is something that can be trusted. So input validation ensures exactly this trust that a provider or the service provider should give to the input given or submitted by the user. So in this example here, you can see that one of the users has tried to register it, and the address, the email address that has submitted, it's not the right one. The input validation mechanism that we have seen here, that we see here, is something that validates the format of the email address, and it recognizes it in almost real time and returns the message to the user that this has to be corrected. The same goes for payment methods as well, or whatever an interaction with the user might be. There are many things that you could consider with input validation. A good way of going forward with this is taking into account the best practices and the frameworks that the security community has provided. Very good example is the OWASP. This is an international organization that provides guidance regarding information security when developing application and software-based solutions. So what we see here is some sample checks from OWASP. For example, you can have data type validators that are available within web-based frameworks and web environments. You can have validation in JSON schemas or XML schemas, and you can verify the input in these formats. You can have some type of conversion between inputted types, so you can take certain figures or certain type of strings and convert them to an acceptable version of that string. And you can have also exception handling when something unexpected is given by the user. You can also have minimum and maximum values in any field or any input that is related to that. Numerical parameters can be benefited from this. You can also have dates validated through this process. And you can also have strings that are could be checked against this type of assessment or this type of input validation. So other types of input validation include array of allowed values. So it's like a list of accepted values that you can take from end users or from interactions. This can include, they typically include small sets of parameters, for example, days of the week, or model types of cars. And there are, of course, much more complex input validations, such as the ones that we have seen in the previous session, including regular expressions for the really, really complex stuff that you would like to check in advance. So more of these details can be found in several sources. A very indicative example of the sources that you can see in these are from OWASP, Input Validation Cheat Sheet. And given this opportunity, OWASP also provides a series of cheat sheets that could help you during your secure software and secure coding processes. So quite a nice and quite extensive source of information. So this is one thing. This is the secure coding thing. On the other hand, you have green software. So again, similar questions. Why should we bother with green software? And there are some obvious answers and some not so obvious answers. The obvious answer is to see your work having a positive environmental effect, to enforce your products or your software-based solutions long-term sustainability. You want this to be relevant. You want this to be still alive in a few years' time. And you also want this to be applied to your code and to your software components as well, not just the whole solution. And this is one argument. Perhaps the least obvious answer is that the fact that we have an increasing level of legislations and regulations that are related to green software. There is a quite recent example from the European Union, which has introduced an import tax law, which says that every single goods that is imported within the European region has to comply with certain environmental rules. If it doesn't, or if it does in a partial way comply with these rules, then there is a different taxation level for this. This also applies to software-based products as well. In case you haven't heard it, it's called CBAM, so it's carbon adjusting mechanism. So it's something that measures the carbon level and the CO2 footprint in the environment, and it's going to be in effect from next year, 2024. So this is something that will come into our hands very, very soon. And lastly, although quite importantly as well, a main answer to why we should bother with green software is because it's our ethical responsibility. As I said in the beginning, we want to leave this planet to at least the same level as we have received it. On the other hand, you also have this question within the context of companies. Why should companies be bothered with green software? So you will see that there is a huge market benefit for that as well. And the green technology and sustainability market size has been raising since the very early measurings of 2017. And it's predicted to triple, quarter, 4 times up, the market size within the next 5 years or 6 years. So it's quite important to consider that there is a huge commercial benefit and a huge competitive advantage for those companies that are going to be involved in this type of engagements. So how we can do that? How this can be happen in practical terms? There are certain ways of doing this, again, in an organized manner. You can see and recognize areas that green IT and green software development principles can be applied. So a couple of these were mentioned also during the previous session, and you can take some samples within this slide as well. So first of all, you must be able to think about the carbon that is being consumed in order to produce the software-based solution. So if this carbon it's more valuable or it affects the environment in a much harder way or in a more severe way than the actual value of this software-based solution, then this is something that needs to be considered, and this burden has to be lightened up. The second thing is the electricity principle, which says that any type of software-based solution should have as low electricity consumption as possible. So this is one of the things that one should consider. Then there is also the carbon intensity, which means that we should consume as much electricity or as much power from renewable sources as possible. So we're thinking about things like location, source power, and things like that. There is the fourth principle, which is related to carbon, which is embodied within the solutions. This is especially for solutions that also have hardware elements. For example, if a mobile phone is also part of the development process, then we should consider what is the minimum level or the minimum volume of carbon that it's included within the hardware device and keeps this device operational and within the requirements that we want. So, for example, this mobile phone might be 1 centimeter thick. It will do the same thing, but it will embody much more carbon than it's needed. Then we go to the fifth principle, which is the energy proportionality. And the easiest way of thinking about that is, trying to minimize the level of hardware that you use and maximize the level of performance that we achieve. So virtual machines, containers are all examples of enforcing and applying energy proportionality into action. And then we also have the sixth principle, which is related to networking. Networking in terms of green software development and green IT principles is related to the requirement of reducing the size of the data and the distance that these data travel. So if you think about a software-based solution that has 3 intermediate nodes, this is much more energy efficient than it is to have the same solution that is dependent on 15 or 20 network nodes. It may do operationally wise and functionally wise the same job, but in terms of energy consumption, due to the number of network components, this will be significantly higher and thus will have the greater environmental footprint. The seventh principle that we have here is the demand shaping. As previously mentioned, demand shaping, it's something that comes along with the other principles, and it actually requires the reduction of load or demand into certain time periods that are much easier to facilitate. And this may also be a factor of the location that the demand is being sent to. So we may choose a different location to satisfy the needs that we have from our customers or our users. The last principle that we see here is actually something like an umbrella principle that includes all other principles. It says that you can do as much with all these things, all these first 7 principles, but in order to be able to understand what is the actual impact of your actions, you have to measure it and you have to optimize it based on those measurements that you're going to have. So measure and optimize in order to prove that any of these first 7 principles or first 7 actions actually do something that it's beneficial in green terms. So all these things aim for corporate and social sustainability and aim also for our own products sustainability, software-based products sustainability. If we want to make like a map of the main areas of green IT, we can also distinguish in 6 areas like energy efficiency, sustainable design and manufacturing, electronic waste management, renewable energies, green data centers, and green software. So all these can be quite extensive. Again, I'm going to take just one example of this and talk about green software example. So let's talk about efficient algorithms. This is the yellow box that you see here is an example of an algorithm that it's a for loop. It actually draws an ellipse, and this ellipse it's performed is done through a for loop that it's repeating itself by calculating this b a square root of a times a, etc. So this is something that consume a certain amount of energy. So an efficient algorithm will be defined as a way of doing the same job with less CPU cycles and thus less energy consumption. So in the green example that you see here, we're trying to do exactly that thing. We have taken out from the for loop the 2 operations that have been repeated without expecting them to have a different result. We have said that these are actually 2 different variables, and these are used within the for loop, not by calculating them again and again and again and consuming energy, by just using them as single values within the for loop. So this is a typical example of reducing redundant operations and redundant loops within a certain algorithm. So the energy efficient algorithm can be any of the things that we can think as redundant loops, redundant referencing arrays, redundant operations, and there may be other flavors like stopping a loop running when it's not needed anymore. You don't have to let it go all the cycles that you want to have, so avoid late terminations. And this is something that can be used in order to measure the computational cost of algorithms. So we have seen something like that in the previous session as well. In addition to what we have seen, I would like to bring forward, however, some sample checks that are taken out from green software development practices, such as reusing the data usage. Think about cache policy and minimum data exchange, compression, compression, aggregation, using a smaller size of data, removing or refactoring unused features from your software components or your software-based solution, detect and remove those lengthy loops that keep consuming energy. And you can also think about adapting software according to underlying power mode. So if, for example, there's a power mode which says power saving, you can reduce the level of detail that you have in a certain image or the resolution. Or you could also have some type of different level of detail or accuracy in numbers, in figures. So the computational accuracy, it's also useful on its own, not only in saving power mode situations, but you can also think about examples like GPS. One could say that GPS within a GPS function within a software could compute with certain accuracy up to, I don't know, 13 digits. This is not really useful in reality, as GPS will also work with an accuracy of 1 meter or 2 meters or 10 meters. So this is something that you can consider when you're trying to improve the green effects within your software code. You can also control features with high power consumption, again, measurement and optimization, and think about common usage scenarios. So what will be the actual usage of the data or the output that is provided. And this is something that you can even drill in more. I suggest to go through the code cracks. This is quite useful source for having these sample checks, this type of checks for green efficiency in your software code, or even the previously mentioned Green Software Foundation, and especially the green software development practices that we see over there. So let's bring those two words together. I mean, there's security in one way, and there is the other way of green software development. From our view, and it's quite important to stress to highlight here that we're coming from a security background and application security in particular. We have seen that there are common ways of dealing the needs of both worlds. So cybersecurity, application security, and green software development actually support multiple requirements such as confidentiality, integrity, availability, the typical ones, but also sustainability for any provided services and managed information. So if you want, you can grab one of these copies here or in our booth and see how these two words come together. We see that software development and green software, secure software development and green software development use the same type of tooling and the same type of frameworks in order to accommodate their needs. So you can have source code analysis serving both worlds. You can have static code analysis, dynamic code analysis, or see and assess your third-party software components for both the needs of green and secure software. So risk analysis is another thing that you can consider. We can include information security, and we can include sustainability risks and threats, and this will actually identify areas, pain points that could be resolved through the application of several countermeasures. Whereas in the situation where information security actually focuses on countermeasures related to security threats and threat actors from cybersecurity, we can combine the threat factors and the countermeasures that are also related to green practices, green software practices. Then we can also have an assessment of vulnerable and energy-consuming software components. So this is a very similar approach and methodology. And we can also think about optimizing our network performance, which is driven by our software-based solution in both cybersecurity and eco-friendly terms. So latest ideas and latest trends could also integrate into that AI-driven mechanisms that could enforce some type of enhancement security control and some type of enhanced energy consumption control. So we can think and identify certain areas in a dynamic way that are more prone to consume energy or have more vulnerabilities. So what we are actually saying here is that these two are two collaborating areas. We can use the same tools, and we can use the same type of methodologies in order to accommodate both worlds. And this is quite cost-effective in corporate terms as well. It's a nice way of convincing our executives that this can be done using the same type of resources. So what's in there for us? I mean, what can we do? So we can think about adopting sustainability and cybersecurity practices in new solutions, in existing software-based projects, in whatever we do from now on. And how we can do that? Let's go back to our organizations and consider building a mixed technical team of developers, analysts, cybersecurity professionals, application security engineers, sustainability professionals, environmental engineers. All these team members could bring their own view, and combined, they could actually set a framework that really works for our environment and our services. So this is something that it will be really beneficial to combine all these views together. So the third thing that you can consider is, see into having a secure and green exploitation of existing methods. The tools and the practices and the frameworks are typically already existing within the environment that we operate. We don't have to reinvent the wheel in most of the cases. So you can think about static application security testing. You can think about dynamic application security testing. You can think about software composition analysis. You can think about the typical quality assurance process that you may have. You can think about the cybersecurity controls and the risk assessments that you do. And you can match this with your corporate and social responsibility reports that in an organizational level one has to do. So if you do this, you will realize that these tools are already here, and the only thing that we have to do is to combine them together and save time while at the same time performing well in ecological and security terms as well. So eventually, this is something that could be beneficial in a personal manner as well. I mean, professionals that could combine these two worlds together, these two set of methodologies together, could become the next generation sustainability and security-driven developers. So, thank you very much for your attention. Find one of these right here. You can take it from the booth as well, booth 22. And we will be happy to answer any questions either here or in our booth. Thank you very much.